So, you get your calculator back for these. Alright. These 3 problems are probably the easiest 3 problems we'll do, but for whatever reason, they don't just click for people. Like, I mean, you don't realize what they're asking you. And so I think, John, this is what you were thinking about before. No, I mean, he was like, he had asked me. Okay. So guys, remember that for our coordinate points, it's always listed as cosine and sine. So if this is our angle of 195 degrees, 195 degrees is not one of our special angles. 195 is like 15 past 180. We don't know a ratio for that. So what we get to do is we actually get to use our calculator here. So we get to take our calculator and do cosine of 195. And so you'll need a calculator for this, because if you can do it again without, you're gonna. I don't like that. Okay, it's ugly. Scary. So cosine of 195. Now, does it make sense it's negative? Yeah, because it's in the negative quadrant for cosine. So we're going to call this like negative 0.97. Let's go. Because that's what I got when I did cosine of 195. Then I'm going to do sine of 195. I anticipate this is also negative because we're in the negative quadrant for sine. So this is negative 0.26. And that's all we do with this one. It's like kind of so easy that you're like, really? That's it? Oh, so if yours comes up with radicals,
we switched it, but at first it's why I was like, yeah.
Yeah, you can use that little button that switches them over to decimals.
Because it's like negative square root of 6 minus negative.
Oh yeah, we don't want all that. Okay. Did you guys find does this make sense? So this one, like I said, it's easier than you think it should be. So 107, we're basically doing the cosine of 107 and the sine of 107. It might be helpful just to think about whether or not it should be positive or negative, but now this one makes sense that sine should be positive because we'd be in the upper left quadrant. So kind of making sure that we're not doing something bizarre and getting these wrong when they're pretty easy to do. Now negative angles you can still put in your calculator. Negative 280 would end up in the last quadrant. Keep on doing 208 instead of 280. Wait, why is... Oh no, it should be in the first quadrant. It spins around. Sorry, I was picturing positive 280. That's what I get for thinking too much. Okay. Alright, so those again are kind of the easiest problems on there, but if you don't know how to do them, it's not like intuitive, you don't come up with those on your own. Alright. So what you guys got? Okay. The next one of the answers is really obvious and the other one is not. And we probably should actually talk about coterminal angles first. So let's actually go to the little, if you look right below this, it says coterminal angles. So I'm going to talk about those first. Basically, they're angles that end at the same spot. So, angles that have the same endpoint. So, I don't have a good place to... So if I have an angle, like a oh gosh. Alright. If I have a 30-degree angle here, an angle that would have the same endpoint, almost picture it as like the hands of a clock, is that 12 hours from now, the clock's hands are going to look exactly the same. You can come back 12 hours from now and let me know. Okay? Jokes. All right. So, I'm just standing waiting. Yeah.
24 hours.
Right. 24 hours and also will be back the same. So we probably could just bypass the 12-hour one. Very smart. So what Carter just pointed out is I suggested 12, he suggested 24. We both named coterminal angles. They both end at the same point. So if I go back around all the way, what's another angle that ends at that same point? Negative 300 would be one if you want to go the other way, negative 300.
390.
So negative 300, but also 390. A positive 390, right? Oh no, wouldn't it be negative 330? Yeah, sorry, did you say? Sorry. I was excited about your answer and then wasn't really listening, sorry. So 330.
I hate that. What does that mean?
We're clapping for the kids.
What?
When we just start clapping.
Do you always clap for Sam or is it for other people too?
It's just for Matthias.
Okay, so if we're trying to figure out the angle that gives us this, if I'm trying to solve for an angle, what's my rule for solving for an angle here? How do I undo this? We do the inverse sign. So we're going to do the inverse sign of this decimal. So you're going to get to use your calculator again. Yay for the calculator, because all right, so if we rounded to the nearest tenth, what would we call that?
47 point. No.
48. We get to round up. So round to the tenths place, and it makes this a lot easier. 48 degrees. They say give us one angle that could work for the sine being that. Now, this is a little bit different than the coterminal. You could just add 360 to it would work. However, now that I say that, I probably shouldn't have showed you guys the coterminal thing quite yet. So if this is 48, where else on this coordinate system is the sine going to equal 0.743? It's the opposite spot. So it's all students take calculus. So it's also going to equal when 48 is over here as well, right? Because that's also going to be positive. What value would that be?
138.
How'd you get that?
90 plus 48.
90 plus 48.
Or 180.
Oh no, you don't want 90 plus 48.
180 minus.
We want 180 minus 48. Sorry. Because 90 plus 48 is giving you a different angle. So it should be 180. We're taking away 48. 132, yeah. A little bit different than coterminal. It just basically finds the other one on that coordinate system that works. So let's try this next one. So we're doing inverse sine, or inverse cosine, sorry, this time. And typically these will round nicely, so this is, you got 36 degrees? Okay. So if we're at 36 degrees in this quadrant, what other quadrant do we want to be in? Where cosine is all students take calculus. So we want to be the other place where cosine is positive. So that's down here, where this is a 36-degree angle. So what's that angle gonna be?
324.
324. So we did 360 minus that 36-degree angle. All right. All right, we'll finish up with the coterminal. They're not too bad. If we do an example of each type, hopefully we'll be able to talk through this. Basically, coterminal angles need to be 360 degrees away from the other angle. So positive or negative. So we want to check the difference between these and see if it's 360 degrees or not. Now, I'm hoping that you can throw out this one right away, because if you add those together, it equals 360, but if you subtract them, it does not. If I take 36 and I spin it backwards, 360 degrees, so if I check the difference between these, difference means subtraction. Oh, not 360, 324. It should equal 360. So this one is yes. How about letter C? So if I add 360 to 600, or 60, we get 420. What if I add 360 again?
Yeah, you're good.
Yeah, so this one actually spins around twice, and we end up with that again. So this one is another yes. The what? Oh, because those aren't 360 apart. They're, all right, and then the last one here, they just want you to find the other angle that would be a coterminal angle, but between 0 and 360. So negative 30 is here. Basically, what's another way I can call this same angle? 330. We kind of talked about this one a little bit already. How about 620? 360 is one time. So we go, that's 180 more. That's 540. Go 9 more, 90. 360 would be, so we have to go to here. So this is 10 short of going, this would be 630. So that's 260.
Wait, why?
Because, so we spun around once, that's 360. We went around here, that got us to,
Yes.
all right, going out that way. You guys get to go outside, brain break outside.